right, guys. And gals. Ooh, I like it. So last time we ended up with doing some, well, we did at least one word problem involving cows and ducks. Yes. Are there any questions? Any questions about anything at the moment? Okay. Quick word for the lab today. I will go over there and start things off, but then I gotta head out very early. So, anybody have lab today? It's gonna happen. I'll just leave you. All right. Page 86. Problem number 1 there about Sabrina. Kind of bragging about her money. No witches. So try to do that problem there. Try to set that up and solve it. Alright, set it. I forgot. 86. To make sure everybody's on the right track. How many variables do you need? 2. What are they? Yeah, so you got the number of 1s, the number of 5s. So the choice of variables is a little bit weird. For 5, you could use F, that kind of makes sense. For 1, you don't want to use O because it looks like a 0. N, well, that's great. So I'll use those. You can use whatever you really want to, as long as you define it for yourself. Use letters that kind of correlate to what they are, so it's easy to tell what the answer is when you get there. You guys see there's 2 equations you can set up related to the 2 sentences for the question. So go ahead, now that everybody understands what the variables are, try to at least set up those equations. Well, some of you guys are just looking at I'm going to wait. Try something. Try something. It's a really good example of a word problem that you can solve without using algebra. But we already had the discussion. All right. If you do get the answer without using algebra, oh yeah, but you get no points. That's too bad. Good job on the answer, but you're in algebra class, so I think that's the main purpose. It's sort of like the whole example of driving class and you walk to the mall, it's not going to work. It's the same idea. What's the first equation I can make here? Yeah. So there's actually that second sentence. I always look to see if there's a total kind of idea. There's a total of this or a total of so many animals, I think the other, whatever. There are a total of, just a total of bills here, right? So you look for that because that's going to be the one where it's just variable plus variable equals total. That's awesome. So I know that if I add the number of $5 bills to the number of $1 bills, I get 22. That kicks ass. Now the other one is going to be the money equation. People make a mistake. They write F plus N equals 50, but that doesn't make any sense because I have to add money to money to get money, and F ain't no money. F is a number of bills. That's not money. So if I have F $5 bills, how much money is that? 5F. If I had 2 $5 bills, I would have 5 times 2, $10. If I had 8 $5 bills, I'd have 8 times 5, 40 bucks. Right? So if I have F $5 bills, I have 5 F dollars. What about if I have N $1 bills? It's $1 per, right? So $5 for every $5 bill. $1 for every $1 bill. It's crazy. And when I add all that together, it's supposed to come out to be, as long as you didn't get gypped in the change, right? That's 50. And now, the nice thing with the word problems, I basically let you use, in the test, there's going to be a section where I say, use substitution, use graphing, use elimination. And then I just give you word problems, and you can choose whatever the hell you want. So, if you haven't yet, go ahead and finish that out. Choose a method, and solve that sucker. If you get a negative number, it's probably a good sign that you've done something wrong. Negative money, that's a bad situation. So bail me out, what method are you trying to use? So one method is substitution. It's a good option for that because there's a lot of variables that have a 1 coefficient.
Or I'll use elimination.
Or you could use elimination, sure. So let's try substitution first. If you take the first one and you solve for either letter, right? So if I take the first one, for example, and I solve for N is 22 minus F. Is that cool? Now, if you didn't do it this way, you're fine. If you did elimination, that's fine. I'm going to do that second. And now I can use this information in this other dude here. I know what N is, so I can rewrite the second equation as 5F plus 22 minus F. So I just took N and replaced it with what it is. And now should be the easy step. You get 4F, subtract 22, you get 28, divide by 4, you get 7. What does that mean? 7 $5 bills. That's right. So I have 7 $5 bills. So how many $1 bills do I have? Yeah, 22 minus 7, that's the $1 bills. I have 15 $1 bills. Or Sabrina does. I'm not taking her money, I'm sorry. Make this word problem longer than Jeff Bugs right now. I didn't do anything. Wasn't me. Alright, so what would that look like if I used elimination instead? So let me set this up again. I had F plus N equals 22, and I have 5F, 5 plus N equals 50. Which letter do you think would be easy to kill? The N. And how would you do that? Yeah, I could take this first one and I could multiply by -1, so that the ends will cancel. You guys see that? Right now, nothing will cancel. I always get somebody that just adds those and gets 6f plus 2n equals 72, and then they put a question mark. And I circle the question mark because I have a question too, am I right? The whole purpose of the next step in this, in substitution or elimination, is to get rid of one of the variables, either directly or by replacing it. Right? If that doesn't happen, you're doing something wrong. So if I do multiply this by -1, I get -f minus n equals -22. I get something that looks very familiar. 4f equals 28. F equals 7. And then hopefully you understand, if you plug 7 back in, we will get 15. So there'll be 15 $1 bills and 7 $5 bills. You can do it either way. There are 2 methods up there right now. Either way is fine. Okay. All right. Any questions about that idea? All right. So let's do some, hopefully you understand. This is the easy word problem. Let's do some harder ones. This. First was not that bad, to be honest. It's a little bit like the one we just did. Try example 1. It's only harder because they have some more disgusting numbers in there. But it's pretty much exactly like a couple we've already done. Try to do that one there. This is page 88, by the way. Normally for me, the letter S is a little tricky because it looks just like my 5. Or the other way around. But I'm going to try this. I have a feeling you guys might have done this. So there's a number of single dip and a number of double dip. So we'll call the number single dip becomes S. Even when you try, John, it looks like a 5. We'll call the number double dip. Cool, I like it. So this isn't always true, but you take a look to see, is this a total kind of problem? Is there a total that will be an easy equation? And is this? Is there a total number of something?
Oh, yeah, 107. Oh, total cost.
Total combs, yeah. There's a total of 60 combs. Now the other one's going to involve bringing the money in. That's going to be a little bit more complicated, but not too bad. So if I take the number of single dip combs plus the number of double dip combs, I should get 60. Now how do I bring the money in? Same way we brought the legs in for ducks and cows. If you weren't here, that's a really weird phrase. And the same way we just brought in the $5 per and the $1 per for the 5s and the 1s problem. If I buy S, single dip, I love this clones, it's awesome. Just realized that. Yeah, yeah, so for each one of these, it's 250. So it's going to be 2.5, you don't really have to write the 0, but I will. 2.50 S. So if I bought 10 single dip cones and ate them all on the way home, it would be 250 times 10, it would be $25 to get that. Plus the cost and how I feel later. What about for every double dip cone? 415. So it'll be 415 per double dip. Now this is money plus money. It's got to equal money. And I know, just saying that, you guys don't understand what, but this is a quick check. When you make an equation, make sure this thing represents this plus this thing represents the same thing. Equals that thing. You can't have number plus number equal money, or money plus money equal cows or something. Right? You just make a quick check to make sure it's all making sense. So what's the money on this side? That's the 179.70. I like. Now the numbers are a little bit gross, but oh well. They're real life numbers. Right? Try to finish that out. And yes, you would be able to use a calculator on this kind of problem. You're not math 88 anymore. Just assume you know how to do this. So which method is somebody using? Anybody using? Elimination, substitution if you want. So if we do elimination, that's my favorite, so that's what I'm going to do. What would I multiply number 1 by? For example, negative 250. What's up?
It seems longer.
Oh, the elimination method? Oh, I'm crazy. So times negative 250. So it'd be negative 250s, which makes sense. We want those to die. Minus 250d equals, and 250 times 60, 150. Negative. Is that cool? Oh, you guys got calculators? Real quick. 2.5 times 60 is the same thing as 5 times 30. Because I could steal a factor of 2 from the 60 and put it on the 250. And a lot of you guys are like, I got this joke. I understand. We're not living back in the 1800s. All right. Is everybody with me so far? So obviously with word problems, there's 2 levels. There's number 1, can you set up the equation or equations? And then number 2, can you solve the damn things? So when you put these together, bam, what's 415 minus 250? Yeah, 165. And that equals, what's 179.70 minus 150? 29.70. And then you do a little prayer. 1.65, does that go into 29.70? Thank God. doubt that they would sell somebody 1.38 cones. You get that is probably wrong. Even half a cone. How do they cut it? Chop? Look at it like a bowl? No. So D is 18. So then what's S? 40. Yeah, it's got to make 60, so it's got to be 42. I like it. 40, 18, double dip. 42, single dip. Okay. Yeah. Example 2 is the same thing, so let's do example 3 because that's not the same thing. Not quite. It's a little bit different. Example 3. Yeah, the nut company. Now we're going to do this one together because it's a little bit different. And I'm going to show you a way that you can set it up if you want to. Some of you guys might not need this, but there's a little chart you could set up. There's a very easy equation to set up, but the second equation is not necessarily as easy. There's a thing you can make a mistake about. So let's try to set it up directly and see what you guys think. What are my variables going to represent? What about them?
They are per power.
The number of pounds. I love it. So the pounds of pistachios, and the pounds of almonds. So amazing, I'm going to call pounds of pistachios P, and the almonds A. That's correct. So now the thing about it, it's not that difficult. So this isn't quite the problem I want to do. So one equation I could set up. Beautiful, because P and A are both pounds of nuts. So they're going to equal some kind of pound. So it'll be P plus A is the total pounds, 50 pounds. Good Lord, man. Throw that in the back seat. Go home. You're set for the night. Damn, you have 10 cones, go home, and 50 pounds of nuts. Now, the mistake people make here is a subtle one. But how do you think the next equation starts off? The pistachios are 650 per pound. 650p, I like it. Plus 8a. So that's the mistake people make. Alright, watch. That is money plus money. Money plus money cannot equal money per pound. That doesn't make any sense. Try again. What is 740? What's the units on the 740? Dollars per pound. So I can't say $5 plus $10 equals 28 bucks per pound. It doesn't make any sense. I mean, really break this down. Isn't each element of this equation money per pound times number of pounds plus money per pound times number of pounds? Look at it. Isn't that what it is? Yes. So the other side better be money per pound times number of pounds. So what's the money per pound at the end of the mixture? 740. And how many pounds is the mixture? 50. So that's the one extra little step, is to realize you got total money on one side. You better have total money, not money per pound. You better have total money on the other side. I love it. Love it. Do you guys see that? I mean, this is a level of mathematics that sometimes isn't referenced. You can actually make sure that the physical reality of the equation makes sense. questions about what's happening so far? Some of you guys are like, I only have one question. When is it going to stop? If you pass, it'll stop at the end of the semester. So real quick, I can clean up number 2 a little bit. 6.5 OP plus 8A equals 740 times 50 is 370?
Yes.
Make sure that's 650. Alright, cool. And now you can do whatever you like. In fact, look between 1 and 2 here. We cross that out now. We kind of cleaned it up. What variable might you want to kill? A. Because the coefficient of A in number 2 is a nice whole number. Does it really, really matter? No. But again, you have flexibility. You can choose which one you want to kill. I'm going to kill A because I just have to multiply this by a whole number, by 8. In fact, by negative 8. So if I multiply this first one by negative 8, I'll get negative 8p minus 8a equals negative 400. I like it. And again, you could use substitution if you want. You could kill the p if you want. If you hate pistachios and you want to kill them symbolically, you can. So on this side, this sometimes freaks people out. You get a negative number over here, but it's fine, because you're going to get a negative number over here also. So 370 minus 400 is negative 30. The a's go away. 650 minus 8. Negative 1.5. Yeah. And then when you divide by negative 1.5, you get p equals 20. I like it. 20 what?
Pistachio.
Pounds. 20 pounds of pistachios. So how many almonds? How many pounds of almonds? 30. How'd you guys get that so fast? Because they got a freaking add to be 50. Oh, 30 pounds of almonds. And then I'll be back the next day for another order. So yeah, these are word problems. They need units at the end. You could lose points if you don't put the units. I'll at least be a dork and say, you know, pounds and tires with that. Yes?
So if we get a word problem, doesn't really matter like what.
Exactly. So like I said, I normally have the nuts and bolts like non-word problem. Just here's a problem, use elimination. Here's a problem, use substitution. Here's a problem, use graphic. And the word problem, I'm just like, set it up and do whatever you want to. All right? Now, I want to talk about this in a not so mathematical way, believe it or not. Just at first. You got a 5% solution of acid and a 30% solution of acid, which means it's got 5% acid and 95% something else. Right? 70% something else and 30% acid in the other thing. You guys with me? Okay. How many liters of each should be mixed to obtain 100 liters of a 20% solution? Now, if I used equal amounts of each, shouldn't the result have right in the middle of the two percentages? Does that make sense? So one way to look at this is, I have a 30% solution. If I start adding some 5% solution, I am diluting this, am I not? The 30% solution, I'm bringing it down. Now, if I put a lot of the 5% solution, it's going to get closer and closer to the middle of the two. Are you guys with me? And if I use a lot more 5%, it's going to start coming down to 5%. Are you guys understanding this a little bit? So am I going to use more of the 30% or more of the 5%? What's in the middle of 5 and 30? How do you find the middle between two numbers? You take the difference and cut it in half, or you just take the average, really. What's 5 plus 30 divided by 2? 5 plus 30 is 35. Divided by 2 is 17 and a half. So if I used, stay with me now. I love you guys. If I used equal amounts of each, the final mixture should have 17.5% acid. If I use equal amounts of each, think about it. Let that make sense. So which one must I use more of so that it actually is 20%? If I use more of the 5%, you see how that's going to bring it down. So I must use more of the 30%. That's why it's higher than it would have been if I used equal amounts of each. Now, thank you for, some of you guys are suffering. Do you really have to understand what I just said to do the problem? No, right? But I want to at least show you can step outside of math for a second, just think about the problem in a different way. You don't get the answer, but I know the answer should be a higher number for the amount of the 30%. Is it crucial to know that to solve it? No. But you still should be able to look at it a different way. So how the hell do we solve this shit? So this is the one I'm definitely going to show you a little chart. Okay. This chart's kind of nice. We did a chart for like distance, rate, time problems. Alright. So we have a 5% solution, a 30% solution. And at the final, it's going to be a 20% solution. Final mix. So I put the amount times the percentage equals what we call the solution. So for example, let's stay with me. If I had a 5% solution and I've got 10 liters of it, let's make it easier. If I have 100 liters, I should probably not be holding of a 5% acid solution. Oh shit! You do not have to know chemistry to answer this question. I think some of you guys just turn off. I never took chemistry. What the shit? No, 5% of this is acid. 5% solution, 100 liters. How many actual liters of acid is in this thing? It's a 5% solution. There's 100 liters of it. 5% solution. 100 liters. There will be 5 liters. 5% of 100 is 5 by definition, right? What's 5%? 5 out of 100. So if it's 100 liters, 5% solution, there's going to be 5 liters of acid. Now it's been mixed up with 95% of something else, so that it's diluted so that it doesn't like boil through its container or something. Do you guys understand what's happening? A little bit? No? No. So it's sort of like saline. If I say saline, do you know what that is? Or let's even do this. Chocolate milk. Chocolate milk. You guys heard of chocolate milk? So I start with pure milk. And then I put some chocolate in, right? Now, I'm not going to have like 90% chocolate solution. That's when you pour the milk into the container of mix. You go, it's so dry. No. Probably not a good idea. But if I put some amount, so I have this much, and I put like 5% of it is my mix. So whatever this is, 5% is going to be my mix, and I mix it up, it's going to be a little bit of chocolate, right? And you're like, no, I like chocolate. So you put another tablespoon. Now it's 10%. You with me? Now it's 10% of a mix. So you guys with me? Yeah. So if my cup is, if I have something that's 8 cups big, right? I'm making a big old batch of it. 8 cups big, and it's a 10% chocolate milk solution. How many cups of chocolate did I actually put in there? If I have 8 cups, it's a 10% solution. There will be 10% of 8. I put 0.8 cups of chocolate in there. So before I put any chocolate in there, it's a 0% solution. 0% chocolate. There's no chocolate in there unless that cow had something interesting happening. right? Just working on chocolate, right? And then I start putting chocolate in there. There's going to be a certain amount of chocolate I could put in so that it becomes 10% chocolate. It's not all milk anymore. There's a percentage of it that is chocolate. How are we doing? All right, is that better than acid? I think maybe. Acid, you're like, I don't want to be near that, so I don't want to be near that discussion. Chocolate milk, okay. All right, now if you're lactose intolerant, I'm using like almond milk or rice milk. You guys with me? In case you were put off. So what I'm trying to say is, what did we do? What did we do to figure out the actual amount of chocolate? We did the percentage times the amount. And that tells me the actual amount of chocolate that's been swirled around in there. So, that's why it makes sense. How much actual acid is in the final solution? Let's start there because we know stuff. What's in the final? What's the amount of the final? 100 freaking liters. And what's the percent? We actually write in here, we write this as a decimal, remember? 0.2. So what's 0.2 times 100? 20. So if I have 80 liters of, I don't know what you mix acid with, to be honest, I'm not a chemist. 80 liters of non-acidic liquid, and I put 20 liters of acid, that becomes a 20% solution. Because 20 out of 100 of it is acid. I like it. I like it. So that makes physical sense. So what I want to do then is do the same thing with this. The only problem is I don't have a freaking clue. I'm sorry, but these are. So guess what my two variables are going to be? Those two crazy things, right? So here we have, how much of the 5% do I have? I don't know. Sure, let's call it X this time. Let's go back to the old days. How much of the 30% solution?
0.0.
Y. I like it. I could tell. You're still right, so I'm not too worried. Done with it. No, you're not. You're still You guys notice? Well, let me finish this out. Now, what percentage, what do I put here for 5%? I put 0.05. I like it. We're just a little ahead of us here. And what goes here? 0.3. And now do the same damn thing I did here. I just don't know what X is yet, but whatever it is, how much acid would be in this thing? 5% of X, so 0.05X. And how much acid would be in this crazy thing? 0.3Y. So there are two equations sitting up there. The amount of 5% plus the amount of 30% has to equal 100. So there's one equation right there. That kicks ass. And then this, the amount of acid in that plus the amount of acid in this better equal the amount of acid at the end. That only makes physical sense, right? Hopefully we're not pouring acid all over. So we got one equation is X plus Y is 100. And another equation is the amount of acid in that one plus the amount of acid in that one has to equal the amount of acid in the final mix. I don't want to be in that lab mixing this freaking acid. Or is this like a Breaking Bad situation? I don't know. Maybe put it on the ground floor. You don't have to watch that show to be able to do it. Now, just to remind you guys, you can do something if there's decimals in your equation. You can kill them. Because decimals are just fractions. Fractions and discounts, right? Because 0.05 would be 5. Sorry. 0.05 is 5 over... 0.05 is 5... 100. Thank you. All right. And 0.3 is 3...
Over 100.
30. Tenths. There you go. We're not just doing cheers. So, 5 over 100, 3 over 10. I can multiply that second equation by 100 and kill the decimals if I wanted to. You guys see that? So decimals really freak you out almost as much as fractions do. You can kill them the same way you do fractions. So if I wanted to, I could take equation 2 And look, it's not a reaction, but I don't want to do it. See, if I multiply by 100, then move the decimal over twice. So once twice, that'll be plus 30y equals once twice 2,000. The trade-off for multiplying by 100 or something is going to get larger numbers in the end. Did you have to do what I just did? No. You can do substitution elimination with the decimals, it doesn't matter. And just pretending like we don't see that you can divide this by 5, because you totally can. I could do elimination by multiplying the first equation by what? Negative 5. So I get negative 5x minus 5y equals negative 500. So now it should be the easy step. 25y equals 1,500. So y equals 60. 60 what? Liters of 30%. So how many liters of the 5% solution?
40. No.
Yeah, x will equal 40 liters. Does that match up with the thing nobody understood at the beginning? There should be more of the 30%. Yes, it does match up. There's more of the 30%. Love that shit. Holy shit.
Yes.
Alright, that's enough. I'll see some of you guys here in a minute and then I'll leave you.